Simplified are us other guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Hello, 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 hello.
Hello.
What's up? Am I audible? Is the sound? Can you hear the words that are coming out of my mouth?
Yes.
We're good. Uh, for now, we don't have any topics in request as such. Like, we don't have any. So we're just doing what everyone else should be doing the second term, more especially for your grade, which is analytical geometry. And some of you, because I've had one-on-one session with some of you, and it's just two of us anyway. It's like I can't see some of you, one of you, because it's just like us. But Mr. Man, on the other hand, have you guys started with analytical geometry?
Yes, we have.
You have, man. That's what you are doing now, probably. Ne? Have you realized? Have you realized that this analytical geometry thing is just the same as it's been in, say, you are in grade 11. It's been as you were in grade 10. And probably even when you get to grade 12, you'll find it to be the same as when you were in grade 11. So it's just more or less the same thing throughout. We're going to talk about some of the secrets that we need to encounter on this thing, because so far, you guys are very intelligent people. I know at this moment, you guys knows how to calculate the gradient of given something. I know you probably, given that you have been taught so far or not, you may be able to calculate the distance between 2 points. Excuse me. The third part, which I think you probably do know already how to do and were expected to know, would be to calculate the midpoint of a line. When you have 2 points at the end, you are able to get the midpoint. Most of these things that I'm talking about, you are 100% familiar with, ne?
Yes.
Great. Now, I'm just gonna avoid, since we are already familiar with the concept of analytical geometry, I don't think there's a need to go from scratch. We can just put each other under hot water from the way things are, and we just take any format of a question we can get. So I'm thinking, let's have just wanna share a picture. Okay, I was trying to share it. The technology, I think I should just open it and then share it like that, because what I'm trying to do, it's bigger than me in terms of the technology. Let me go here. Okay. There we go. Let me just maximize. Okay. Can we all see the question?
Yes.
Right. Uh, okay. All right. Now that we can see the question. Okay, everyone, it appears fully as it is. Because I had to crop
Yeah.
it so it can fit on the screen. Perfect. Nice question, which comes as a form of probably a total revision to most of you guys. But I'm interested in one thing. If you see this type of a question, what comes first to your mind before you even answer that question?
Which one? The gradient?
Just the structure of the question as it is, J. So the points D, -1 and 2, E, 4 and -2, F, -5 and -3 are vertices of triangle DEF. Does your mind allow you to see the triangle?
Mm,
Yes or no?
yes.
Yes. So you can see the triangle even without drawing it down,
Um, I think
because
so.
you have to be on the level of Sheldon Cooper and them to be able to see that structure, as perfect as it may be. So you do see it in your head.
I don't know, but
Kakadlala, man. I'm just playing the devil's advocate, but be confident. Don't care. Don't care about what I say. I just wanted to see. But if you can see it, I'm not judging, man. If you can see it, it's a good thing. But I was saying it because I was gonna say the first thing that needs to be done when you have a question like this is to draw the structure first on the side before you touch any of the question. That's what I was gonna say. So before you even try, because it's gonna help you to even tell which quadrant it is for each. And I think you can tell which quadrant it is for each, because let me remind you something. Do you remember, Hore, in the Cartesian plane? Okay, what did I do? So in a Cartesian plane, the way your normal Cartesian plane, the way it should be, you would have why is it drawing to? Okay, let's take it from here. It's fine. I can explain it better from here, the traditional way. We'll come back to our questions. So in your normal Cartesian plane, we all know in a normal Cartesian plane, we all know that according to the points here, both x and y are positive, because obviously this would be the y-axis, this would be the x-axis. So here both x and y are positive because we have positive y-axis, positive x-axis, negative y-axis, negative x-axis. So in terms of a point on the second quadrant, x is negative and y is positive. In terms of the point on the third quadrant, both x and y should be negative. And then in the fourth quadrant, you know that x will be positive, but y will be negative. This is what should live in your head every time you are constructing diagrams that has points. So now on our given question, we have point D, which is -1 and 2. And then we have point E, which is 4 and -2. And then we have point F, which is -5 and -3. Now, let me come back to our structure. So now these are the points that we have. I have drafted them down. Here they are. So from these points, the reason why this theory is very much important is because these points helps you to know in which quadrant is each one of these already. One.
Yes. Yes.
So where would we draft the first point, D?
In the fourth quadrant.
On the fourth quadrant, D. Look, fourth quadrant, x is positive, y is negative. And the point, always the first value represent x, the second value represent y, meaning it's actually D. Negative x, positive y. So it's on the second quadrant.
Oh,
So
yeah.
if we, yes, so if we plot it, we can picture -1 to be somewhere here. And we can picture, say, +2 to be somewhere here. Or I can even put it a bit higher to be somewhere there. So we have the point is there. So that would be our point D, which is -1 and +2. Great. Where would be our second point, E?
Fourth quadrant.
In the fourth.
The fourth quadrant. So for E, we can imagine, say minus, because this part represent Y, this part represent X, and this value represent X, this value represent Y. So for X, we're gonna count and say, suppose we have 1, 2, 3, 4. We can say our +4 is somewhere there, and then our -2 can be -1, negative. So it could be proportional to that. So -1, maybe we can put it somewhere here and have our -2 here. Therefore, our point E is there, 4 and -2. We are getting somewhere. Now, where should be our third point, FB?
Third quadrant.
Third quadrant, because they are all positive. So third quadrant, we can imagine, yes, we can imagine our x to be -5. So -1, -2, -3, -4, -5. So -5 is there. And then y is -3. -3, since it's -2, -3 may be somewhere just above here. Therefore, we have -3. And then if we join the 2 points, therefore the 2 points will meet there. That's when we have f. Our f, which is -5 and -3. So ideally, even if our structure is not perfect, but we have that structure. Let me just remove this. It was just for reference. So even if our structure is not perfect, but we have that reference, let's go back and see what else do they say. Somehow they are saying those points are vertices of triangle DEF. So we're gonna go join the vertices of triangle DEF. So this is triangle DEF. So it may not be accurate, but you can see what's going on there, right?
Yes.
And then from here, you can brag all the way you want. Now, 1.1, we have to get the gradient of df. The gradient of df. Now, 2 marks. That's not a problem anymore because we know we are good in that part now. So you do your thing. 1.1.1 gradient of df is going to be y2 minus y1 over x2 minus x1. This is going to be, you can choose which one you want to be your y1, you can choose which one you want to be your x1. So suppose we say this is our x2, y2, this is our x1, y1. So it will be -3 y2 minus 2 y1 over -5 x2 minus -1 because it's a negative. Therefore, we would have -5 over -5 plus 1, which will be -4. Therefore, it would be +5 over 4. That would be the gradient of df. Easy peasy, right? I know it's just revision, like I say, just the revision of stuff that we already know. If line DE is perpendicular to DF, write down the gradient of DE. Let me go back there. If DE is perpendicular to DF, so now the story comes. If DE is perpendicular to DF, write down the gradient of DE. I think you already know what question they are asking you here, ne? There's an honest relationship behind gradients when 2 lines are perpendicular. And we know it, we sing it all the time. There's something that happens when 2 lines are perpendicular to each other in terms of gradients. And those theories, there are type of theories you must know. Like for instance, for example, if 2 lines are parallel, we know that they have equal gradients. Do you guys still remember that? Or when lines are parallel, they have equal gradients. Yes, no, might have forgotten, but that's what it is. Anyway, when lines are perpendicular to each other, when you multiply both their gradients, you must always get a value of -1, which is the reason why they presented the question the way they did. So look at the question. The question is saying, if line DE is perpendicular to DF, write down the gradient of DE. If line DE is perpendicular to that, then you are writing down DE. So, in other means, what is actually being said here is I was trying to share both the screens. As things like this, they need proper manual maybe. But anyway, we can do it from here still. So if this line is perpendicular to this line, we must write the gradient of DE because they relate. So I can just write it somewhere on the side here and say 1.1.2 1.1.2 would say gradient of DF multiplied by gradient of DE must be equals to -1. Must be equals to -1. That's another rule of how things are by general. Gradient of DF multiplied by gradient of DE, it must give us -1. It's just an equation of some sort of a situation of two lines that are perpendicular to each other. Automatically, when you multiply both their gradients, you must get -1. It has been proven. We could even prove it ourselves, but it's just that the question is not about that. The question is just about stating the gradient of DE. So you're just gonna go ahead and substitute the gradient of DF where you have. So it's just gonna be 5/4 times MD is equals to -1. And then from here, you are just solving for gradient of DE using your maths the way you know. So if you have this, it's either you divide by 5/4 both sides, or you can cross multiply the 4 with the -1 and then you divide by 5. But oxalayo, whatever way you solve it, gradient of DE will be equals to -4/5. That's where it's getting at the end of the story. But still, I'm certainly confident for you guys, it's just that, like I say, we're just revising, but I'm certainly sure for questions like this, if you were writing a test, you would be fighting for these marks. And I know you were probably going to get them somehow. Anyway, let's look at the next scenario. The equation of the line DE in a form of y is equals to mx plus c is our next scenario. The equation of DE. Guys, we all know that to find equation between 2 points, that part we have mastered it in so many different forms. Ghana, we said what happens when we try to find an equation between 2 points? Anyone who remembers? Given that we are allowed to be wrong. To find the equation between 2 points, you have 1 point this side, 1 point this side. You just have to determine the equation in the form of y is equals to mx plus c. This is probably the stuff that you learn in grade 8, 9. But I know you remember, ne? I'm just gonna assume you remember and we proceed, ne? Because anyone wants to save the day between the two of us, between the three of us, except me. Between the two of you, anyone wants to save the day, how to get an equation of a straight line between 2 points given y is equals to mx plus c. The m stands for the gradient already. So the m already stands for the gradient. So we must represent the line in the form of y is equals to mx plus c. We already have the gradient of md. I mean, we already have the gradient of dE, which we just determined now, which was minus 4 over 5. And within that, we already have point D, we already have point E from our thingy. So if I substitute the gradient, I would have y is equals to minus 4 over 5x plus c. So I'll just have to find the value of c only. And to find the value of c, I can either use point D from that line that I have on the diagram, which is on the other page. I can either use the point of D, which is this, or I can either use the point of E, which is this, to find the value of C. And then to do that, I will say y is equals to minus 4 over 5, where the, okay, let me substitute Sumara from here. So, because I'm looking for the value of C, I'm deciding to use D, minus 1 and 2. So, where there's y, I'll put 2 is equals to minus is equals to minus 4 over 5, where there's x, I would put minus 1 plus c. And then, because the goal is just to put the equation in the form of x plus c. And by doing that, you just have to find the value of m and find the value of c. And then you leave x and y as they are because you are determining the equation of a straight line. So here, the next step is just to solve for c. Now that part is your knowledge of your maths, but you would have 2 is equals to, when you multiply the negative, you would end up having something like positive 4 over 5 plus c. And then depending on how you choose to solve that thing, but if you choose to multiply by 5 throughout, you would get that 10 is equals to 4 plus 5c. Therefore, take the 4 to the other side. 5c will be equals to 10 minus 4, 6. Therefore, c is going to be equals to 6 over 5. Meaning, your equation for 1.1.3 is y is, okay, let me get a colorful. So, it is y is equals to minus 4 over 5 x plus c, which is 6 over 5. It's over 5 there, which is 6 over 5. If you want, if you don't like the equation when it's like that, if you want, you can multiply by 5 throughout and write, no, don't, because they said you must write it in this form. Exactly. Y is equals to mx plus c. So you just have to put m where there's m and c where there's c, which you calculated yourself. So you leave it like that. That's how you get your 3 marks. Straight to point. Now, it's getting a bit interesting. 1.1.4. These are the type of questions that you wouldn't answer if you didn't have the structure. I swear. These are the questions that you wouldn't answer. You wouldn't be able to answer if you didn't draw the structure. And I still have the structure drawn. But here is the question. The equation of a line parallel to DE passing through point F is, okay, in the form of y is equals to da 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 da. Which one is that? So we are looking for the equation of a line that is parallel to DE. and that line passes through F. So we go to our structure. Line parallel to DE that passes through F, and we have to determine the equation of that line. Interesting. Okay, let me interesting stuff. So we still have, let me just remove this part. We're gonna use it in, we're gonna have to remember the values if we need to use them at some point. But here's the story. If DE, it goes like that. We are looking for a line that is parallel to DE that passes through F. So this line we are looking for should be constructed here, parallel to DE, but it passes through F. So if I construct that line, it will look something like this. It's not going to be according to scale, obviously. That's the line. This line is parallel to DE, but it passes through F. And I must determine the equation of that line in the form of y is equals to da 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 da, da which they never said. So that da 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 da, da which they never said, since it's a straight line and it's parallel to a straight line, is still gonna be in the form of mx plus c. Still, because a straight line is in this form, vele. A straight line, we call it a linear function. A linear function is by definition like this, vele like that. So now, looking at what is expected from us is this equation of a line that is passing through DE. We don't have too much information about it, but imagine we only have 1 point. We only have 1 point in question regarding this line. Does any one of you has any opinion or planning of how do we go in approaching this part? Because we need at least 2 points to get an equation of a straight line. What is the secret that is hidden from us on this question? Based on this. Anyone? You must warn me if there's someone next to you in the room such that you can talk. So I don't wait for an answer, guys. You know, I'm saying this because one student told me, hey, if there are old people in the room, I can't even laugh at the joke because, hey, I don't want them to think like, hey, you are not taking school serious. You know that.
Did we find the gradient for DE?
We did find the gradient for DE. Remember the gradient for DE, we got it because there was some perpendicular happening. So the gradient for DE, we found it to be minus 4/5.
So the gradient for that line parallel is also negative 4/5.
Aha, because parallel lines have equal gradients. That's the punchline of this question. So as much as they didn't communicate to us, the punchline that they were trying to throw to us was that what happens when lines are parallel in terms of the gradients, but without them really saying it. So now we are happy because we already have the gradient of this line, which is minus 4/5 that we're gonna substitute there, plus C. And to find the value of C, we just need 1 point. And that point would be F because it is passing through F. So we're gonna take the point and substitute where there's X and Y in order to get C. And then to do that, for Y, this would be minus 3 is equals to minus 4/5. And then for X, it's minus 5 plus C. Look at things becoming even easier because now we know what's going to happen to the 5, but we can just do it directly. I don't know how you prefer to do it. The 5 can just cancel, you multiply the negative that side. But anyway, for safety reasons, let's just say minus 3 is equals to 20 over 5 plus C. Therefore, minus 3 is going to be, you know that 20 over 5 goes 4 times into 20. Therefore, if you take the 4 to the other side, you will have your C being equals to minus 3 minus 4. Therefore, your C will be equals to minus 7. And then voila, you have found your equation, which is y is equals to minus 4 over 5x minus 7. Just like that, you win. All because you were able to remember that when lines are parallel, their gradients happens to be equally so. Okay. You know that there's always that one question. I think it's gonna be the one with 5 marks. Whenever I see more marks, I just know like, oh, we have to work. But we are not worried. You know why we are not worried? Because we have our diagram. With this, any weapon forms, any weapon, for those who went to church, any weapon formed against us will never prosper through this. Yes. So through this, any question, we are tackling it because why? Before we start the question, we wrote our diagram down. We didn't use our head because some of us are smart enough to remember this in our head. But don't trust your head all the time. Trust me. We always say we're going to remember things and we don't write them down, but we forget the things. Same applies with a diagram like this. If you're looking at it from your head, because when they bring this question to you, no one is advising you what you should do. You just have all the 3 points that form that triangle. If you are trying to work with all the 3 points, looking at them as they are there, I'm telling you, you're not even gonna go past question 1.1.4. You're gonna end up skipping to the next question because you will think still it's only 3 points. I'll come back to it. And there might not be even a time to come back to it because you might see even more hell with other questions if we don't optimize. So by optimization, I'm saying we must whatever scenario we have, we must be able to draw the diagram if we don't have the diagram. For cases where we have the diagram, we must be able to take a moment, 3 minutes nyana, to analyze the diagram and see things that we can point out ourselves before even we approach the question. I will show you when we do other questions related to that, the ones that have an object relating to anything. But anyway, to save time, if G is 6 and Y, and that G is a point on DE, determine the value of Y, 2 marks. So G is a point somewhere in the around DE. Let me go back to our structure. We can put G anywhere, but it's just that we don't know where can we put G. But we know that through this G, the value of G for the X is 6. So this G, if we are to imagine it, it would be somewhere here. Since X is 4 here, this would be 5, this would be 6. Meaning G would be, as the line proceeds, G would be somewhere here. And then if I slide down, G would be somewhere here. Already, before I even solve for Y on G, because that Y for G, it's on the 4th quadrant, I already know it's gonna be negative. These are the important things to analyze while you are enjoying your equation. Do you all agree do you understand why did I put G here? We're still on the same page. Why did I put G here?
Yes.
Yes. And
Yes.
I'm able to construct G because I have an accurate structure. That's why things are like this at the moment. So in order to get G, what do you think I should do, guys? Remember, we have the equation, we have the equation of MD. Kana, what was the equation of MD?
What was the question again?
I'll go back to the question now. 4 over 5x. I think it was
-7.
-7 is for this other equation. It was for this one, the one passing through point D. This one, it also had over 5. The value of C also had over 5. I'm just not sure. It was over 5, and then the top part was okay, we can quickly do it. So I can quickly do it. Yeah, it was 6 over 4. It was 6 over 5, I mean. So from here, to get G, it's not that much hectic. Since you are looking for the value of Y, where X is 6, you just do that. The only thing that should worry you is if your value doesn't come out as a negative value. So, 4 times 6 would give you 24, right?
Yes.
And then negative 24 plus 6, that would give you negative 18 over 5. So that would be the value of Y. So the point G is 6 and negative 18 over 5. Which makes sense because negative 18 over 5 negative 18 over 5 is roughly 3.6. And remember, our 3 is here because of this point. So 3.6. So if 3 is here, probably maybe 4 could be here, and then 3.6 would be somewhere there. Which makes sense, you see, for it to be negative 18.5 because that's 3.6, which is roughly somewhere where G is with the 6. Do you see, because of the accuracy of the diagram, we are able to prove our calculations as well, which is the most important part of when you are applying this thing in reality. 1.1.6, the length of DF is equals to DE. The length of DF is equals to DE. What type of triangle is triangle DEF?
A right angle triangle.
right angle triangle.
Yes.
Okay. You could be right. I'm not saying you are wrong. The beautiful about mathematics is you are open for an argument. You could be 100% correct. But before you choose if you are correct or not, does triangle DEF being a right angle triangle supports the fact that DF is equals to DE?
No.
So even if it's right angle, we know it is right angle triangle because they told us it was perpendicular from number 1.1.4. So already know
So
it was.
then isosceles.
Thank you. Thank you. That's it. It's an isosceles triangle because if this DF is equals to DE, it means we can also assume that also these angles are equal. But the way they ask the question now, I'm worried, Hori. It's 5 marks, bruh. You can't get 5 marks for saying just it's an isosceles triangle. I think we have to determine the length of DF. We have to show if the length of DF is equals to the length of DE. You know why? Because from the beginning of the question says determine and then go 1, 1. So we have to determine the length of DF if is equal to the length of DE. Maybe it's some mathematics because I know you guys, I know when coming to English, there's a difference because the English part of it, you are actually even better than me. So I'm not the one who made the error here. It's probably the people who are responsible for making the question paper. The shadow board. I call them the shadow board. But yeah, they are the ones who are responsible for this. But otherwise, we have to determine those lengths. And then after, we're going to tell, we have to prove first if DF is indeed equals to DE. And then we're going to say what triangle is going to be. So we already know. We just have to prove it. So you now know the distance formula is DF is equals to, do you want to say it out loud?
The square root of x2 minus x1 squared.
X2 minus X1 squared plus
y2 minus y1 squared.
Y2 minus Y1 squared. Because you know the distance formula, let's quickly prove if DF is equals to DE. So coming back to our story, story. But we already know they're going to be equal because the moment they say you must prove something, it means it is like that. If they are not equal, then you should have done something wrong. So DF is going to be, I'm going to take it because my X2 is minus 3 minus 2 squared plus my, oh, no. That's my, but it doesn't matter anyway, but I just want to be accurate for accuracy's sake. So for X2 is minus 5 minus 1 squared plus for Y2 is minus 3 minus 2 squared. Therefore, we would have square root of, inside here would have minus 4 squared plus inside here would have minus 5 squared. Therefore, this is going to be equals to 16 plus 25. Therefore, this is going to be equals to 16 plus 25. Don't wait for the next
41.
person. Don't wait for the next person. It's not a competition. We can leave it here from now because we are just trying to prove if they are equal. So I can do DE and see if it's going to be square root of 41 as well now. So for DE, I'm going to say, I'm going to make my x2 and y2 this side. So I would say square root of y2 is minus 2. Oh, no. Let me start with x. X2 is 4 minus 1 squared plus y2 is minus 2 minus 2 squared. Therefore, this is going to be square root of 5 squared plus square root of minus 4 squared. We already see where this is going. 25 plus 16 square root of 41. So we have proved that DF is equals to DE. Then that's when you would say, therefore, triangle DEF is an isosceles triangle. Clear. Straight to point. No complaint. We're all good. Ne? Hopefully.
Yes.
Guys,
Yes.
if you have a question, don't allow me to pass. Like, you know the story. Once we pass, we forget. So stop at that moment and say, hey man, how do we do that one? The area of triangle DEF, 2 marks. How would you calculate the area of triangle DEF? Since we know it's a right angle triangle. Area of triangle DEF. We are calculating the area of that triangle. What do you guys say? Is a closing question. We can brag. How do you calculate area of a triangle?
Of time.
Very good. So, area of a triangle is equals to half the base multiplied by the height. Half the base multiplied by the height. And already, since this is a right angle triangle, this is going to be your base, this is going to be your height. Because it's a height, the height can be the hypotenuse. This is going to be, one of these is going to be your base and your height. So since they are the same, whichever one you choose to be a base or to be your height doesn't matter. So this is going to be 1/2 times square root of 41 times square root of 41. That's how you answer the last question, 1.1.7. And then whatever value you get here, it would be 80. Okay, yeah, it would be that. 41 divided by 2. Because square root multiplying by square root will eventually remove the caps, and then multiply by the half is just going to be that. So this is going to be 20.5 units. Yes. I'm sorry for writing small little things there. Space, man. Mara, you get the drift, right? If you are following, you will know where we're going, man.
Yes.
So, guys, sequence and series is beautiful. Today I selected just a mere question And just to boost your confidence, this question, I took it from exactly Vele Vele, a grade 11 paper. This is where I got the question from. It's not finished. We're gonna do the other section. The other section is 1.2, is this one. It's not done. But today I just knew it's about weight open. So you can see this was 2022 June paper. For some people who are writing June, I don't know. Yeah. But it's the same stuff. It's just an exemplar from the past paper, as I'm saying. So we're gonna continue from 1.2. But for today, it's fine. We have gotten our part. So the main punchline of today's lesson. Number one, if you're not given a diagram in analytical geometry, it's your responsibility to create that diagram. If they give you a triangle, if they give you a square, if they give you a parallelogram, that's the reason why in grade 8 or grade 9, they teach you how to construct points so you can be able to create shapes, so you can be able to analyze the shapes. So even when you are given the diagram, dude, when you are writing an exam, you are expected to write on that diagram. Play with your pencil, use a pencil even so you can erase, but play with your pencil, construct, construct those lines that I'm talking about, like make things happen on that given diagram until something happens. But you will see, when we go to the circle geometry, which is the Euclidean geometry, you will start to see all the knowledge that you learn from analytical geometry, all the knowledge that you learn from all those theorems, it is placed together to answer those big questions, like the ones that follow from question 9, question 10, where you are searching for angles, relating which angle is what. It's just that I don't have the example or time to can show you the type of a question, but it all builds up from here. So if you fail to follow the rules on simple things like this, like being able to give a diagram, being able to construct wherever you are supposed to construct, in a bigger scenario where now you are having circles that has triangles inside, quadrilaterals inside, cyclic quad inside in different forms, and there are parallel lines, things are alternating. Like, it's just, now you have to use your whole application. And you will see when we do those questions, if you can follow the basic order, when you get there, you won't struggle because you'll be able to give out all the information that you know. But should you fail to get it right from the start, that's when we get it wrong. So from my side, guys, we can call it a day. Given that, I hope we can go back to our consistent practice. Around this time, we're gonna make a majority of either we do maths or physics, but then earlier on we can do our one-on-ones and other groups or other grades. So also, if you are supposed to be attending an other grade or below a grade lesson just to improve something, you can go there. If you wanna attend a higher grade, just to see if your mind can take it, you are also welcome. Do you wanna try that sometimes?
Maybe.
Yeah, like we're gonna do it after towards bigger exams, because the stuff are the same anyway. Like there's a lot of, like 80% of stuff that are done in the following grade, which is 12, they are done in the so it's just the same similar things. I will show you one day in the form of practical manner. But all I'm saying is I'm open to us having as many lessons as we can, but it's just that sometimes time to attend one-on-one, you can't attend everyone, and everyone needs time because we are all doing this thing. There's no one who's special than the other person. But other people, they're privileged enough to can find me at an earlier stage, around 4:30, 3 o'clock, and they'll be like, yo man, I'm home. And sometimes I fail because I accommodated the person who got earlier, but I am working it out such that sometimes it doesn't have to be me who's pushing the lessons. Another person can be assisting someone on serious occasions, because sometimes you find that really that day you need a one-on-one because you are writing in 3 days time and you would need to be attended to. So I'm working on something where other people can attend to other lesson. Because normally the way we do now is like this person has their own students, this person has their own students. So I feel like it's not fair, man. Sometimes someone can be free and we need more people to teach, because all we need to know is just to teach so people can pass. So it's gonna work out. But yeah, I'm still doing the paperwork and the what to get it right. Otherwise, thank you guys. Enjoy the rest of your evening until we talk again. And thank you so much for your time. You can log
Thank you.
out. I'm not gonna close the meeting. You can log out yourselves.
Bye.
Bye. Well, we are professional now. We don't care about 40 minutes, dog.
Okay.
Yeah.
Yeah, see you, sir.
Aye, now new levels. We are.
Yeah,
If you take time, I can even kick you out. I'm just being respectful when I say you can log out.
oh, okay. Okay. Sure.
Okay, let me do this. Let me try to see if I will assist. All right. The reason why I wanted to be alone now is because I want to do the closing on the YouTube part for those who are watching from YouTube. For those who are watching from YouTube, guys, you know, the beautiful thing with mathematics is we can do as many past papers as we can, but something like this, it requires consistent practice. If you feel you have a child who's struggling, if you are not the one who's watching this, feel free, dog, to join us. There's my contact somewhere on our page. Look for our contact, send us a WhatsApp, and then we can put you on a program where we learn daily. We attend to you sometimes one-on-one, sometimes small group discussions, groups which are not even more than 5 people, which is like, also, you know that every tutor is like, I teach for 1 hour this much. We don't even consider how much we teach your child. For a fixed fee, we just keep working and we have results to prove. I mean, we have proof of results that we've done in the past. So otherwise, feel free to join us. This is Simplified RSA as an organization. We are the guys who make it look easy because we simplify everything for you. Until next time.
Simplified RSA, the guys who makes it looks easy. Your number one learning channel.